Hello everyone, thank you all for coming out. My name's Harry Roberts. My talk today is called Big CSS. It's quite a vague title for a talk really, but it allows me to cover quite a broad church. Quite a lot of things come under this, the scope of this kind of title. So over the next 40-45 minutes or so I'm going to talk through some of the stuff that I've been doing in my work at Sky, some of the stuff I've been writing about recently, and some of the work I've done on personal projects, covering the area of Big CSS, maintainability, scalability. It's quite an interesting area of CSS that not a lot of people really get to work with. So yeah, the next sort of 40 minutes are going to be all about that. So I'm Harry Roberts. I write and tweet at CSS Wizardry. It's important to note, however, that I'm not actually a wizard. For anyone who doesn't get that reference, that's Sir Ian McKellen talking about his role as Gandalf the Wizard on Ricky Gervais's Extras show. So yeah, I work at Sky. I've been there about a year and a half now. I work there as a senior UI developer. Currently in Sky's betting and gaming arm as well, so if anyone knows skybet.com, that was me. Sky, as you might imagine, lots of big sites, very big projects that last for a while, lots of developers. And interestingly, at Sky, most of the developers are actually software engineers. They're not front-end devs at all. Where I work, I am sort of the chief knowledge on CSS. So the big projects I work on are with people who don't even write CSS. I have to be able to write CSS for people who aren't really familiar with it. The projects are also UI heavy. I've got UI heavy here. And what I mean by that is they're typically very component based. We work in an agile manner at Sky, so any development work we need to do has to be rapid. We have to be able to respond to change. We need to work with our code base fast and efficiently. So that impacts how we write our CSS, because we might need to skin a component differently for a one-off sort of disposable purpose. Things like that need to be easy. That shouldn't be a difficult task. These are all things that happen on larger sites and longer running projects. In terms of long running projects, I've worked at Sky for a year and a half now, and one of the projects I worked on was to build the front end of a website, and that took over a year. So these are very, very long running projects, and hopefully going on forever. I mean, I moved off this project, it took me a year, I moved off of it, but it's still ongoing. There's other people working on that now. So these sites last for a very long time, therefore we need to make sure the CSS can scale and be maintainable over that time frame. As well as that, I worked on an app called Favourite with a very good friend of mine, Nick Payne. Favourite's a really cool thing we made. It's a web app. You sign in with Twitter, and Favourite goes off and grabs all your Twitter favourites, brings them onto our servers, at which point you can tag them, comment on them, share them, organise them, categorise them, you name it. And this was slightly different to the stuff at Sky in that it was a lot smaller, certainly from my point of view. It was only a handful of pages, and there's only 2 developers. And although Nick is a very good front-end dev as well as a very good back-end dev, I took the CSS lead on this. I had to write CSS that he was comfortable working with, that he could understand. Even though it's only a team of 2, it's a team nonetheless. Again, very UI heavy. We built Favourite mobile first. There's a lot of CSS involved in the responsive stuff. You've got different states of components, therefore there is a lot more CSS to work with. And again, a very long-running project. Now, unfortunately, Nick and I haven't touched Favourite in quite some time. But when we pick it back up again, we need to be able to pick up where we left off. And that's all part of writing maintainable CSS, making sure we can do that. So writing CSS is easy. And it is, it's almost insultingly easy. The syntax is very, very simple, very easy to read. But architecting CSS isn't easy. This is the hard bit. This is the bit people often struggle with. A lot of developers will tell you they can write CSS, and sure, maybe they can float something left or make something bold. But not a lot of developers really understand CSS architecture. A lot of developers code and code and code until something looks like the PSD. Then they move on and code up the next bit, with very little thought to what's actually going on. CSS becomes a bit of a black box. And not a lot of developers consider 6 months, a year down the line. And this is where projects become problematic. This is where you start to run into troubles. It's a lack of knowledge of architecture that allows or causes projects to start spiralling. A really quick example of some recent, like, full-scale architecture that I've gone through is skybet.com. So when I started at Sky, my first job was to rebuild the entire front end. It was getting redesigned. I had the task of building the HTML and CSS. And it's the biggest project by far that I've ever worked on. I used to work on the travel website a few years ago, but that was a team of front-end developers, and when I joined the team, it was already mostly done. It was more maintenance work. Skybet.com was me on my own, and I had to start it off, and I managed to get this project down to less than 10,000 lines. It's not often I say this, but I'm really proud of the work I did here. And I made mistakes along the way, of course, but I learned from those, and yeah, I got the project down to less than 10,000 lines of CSS. And if anyone knows skybet.com, it's a huge site, and that was quite it's quite a difficult task to get the CSS that small. And it's only across 2 files. The first file contained high-level Sky brand guideline stuff, grid systems, the Sky font face rules, and the second file was full of skins, sort of a theme that laid on top of it. So the first file was almost project agnostic. We could have used it on any project we liked. So there's only really one file of bespoke CSS went into making this entire website. I believe it's the notorious BIG once said, "More devs, more problems," and I certainly agree with him. A lot of people are quick to blame CSS for spiralling front-end projects, and unfortunately it's not always the case. A lot of people sort of, they look to preprocessors to fix problems because they believe that CSS is a flawed language. Now unfortunately, I don't really think that's true. And this isn't a witch hunt, this isn't a blame game, I'm not singling people out, but other developers working in style sheets is often what messes them up. As we covered before, not a lot of developers actually understand architecture, so if you're working in a team of people that don't necessarily understand it, you're going to find it hard to carry things on in a nice, smooth manner. You need to be careful of who's working on a project. You need to make sure that everyone understands the rules that you want to work by. You need to make sure that people understand why they have to do certain things. You need to make sure people understand how you work, or why you work, how you work, so that they can do the same. That said, however, CSS isn't without its sort of gotchas. I won't say flaws, I will call them gotchas because I don't think it's necessarily a problem with CSS, it's just things you need to look out for. If we look at CSS in conjunction with HTML, as it's obviously most commonly served, you'll find that your HTML it's viewed in situ, it's very self-contained. It's a markup language, so it's by its very nature, it's incredibly self-explanatory. You look at a piece of markup and you might have a H2 with a class on it. And in that one line of HTML you can see you've got a level 2 heading that has some style information somewhere. Now you open the style sheet and you find that class that was on the H2 and you'll find the styling there, but of course that also inherits from the H2 rule set, which in turn inherits from the HTML element or the body element. So whereas one self-contained line of HTML is easy to read, that translates to maybe dozens of lines of CSS, perhaps split across an entire file. CSS relies on inheritance and a cascade, and probably the biggest gotcha of all is specificity, and I really struggle to say that word, so bear with me. Louis Lazarus, I believe it was, of Impressive Webs, wrote an article saying he wishes specificity didn't exist, and I can kind of agree with him. As soon as you start seeing important in a style sheet, you know that you've hit rough waters. So, important is like the 4 horsemen of CSS. It's a sign that things have started to go wrong, and it's because of specificity. And once you get into a specificity problem, the only way is to get more and more specific. You're digging a hole, you're getting deeper and deeper into the problem. So with this in mind, I believe it's important that we defer more work to the HTML. By this I mean, perhaps use a few more classes, maybe use a little extra markup. A lot of people show off that they can do things with no classes at all, but if you're doing that then the likelihood is it's leading to bloated CSS. If you spread the work more evenly between your style sheets and your markup, you'll find that both become easier to maintain. There's no point cramming too much into a style sheet when you can offload some of that onto the markup. Real brief word on preprocessors. I could forgive you all for thinking that a talk on maintainable CSS in 2012 would be all about Sass, but it's not the case. A lot of people see preprocessors as a silver bullet that will solve all their problems, but if I'm entirely honest, I see them in a lot of cases as more of a fool's gold. And preprocessors are fantastic, but I never think they will replace a sound knowledge of architecture. Preprocessors are just a shortcut. What you've got to remember is a preprocessor only generates CSS, so anything you can make the preprocessor, you could have typed longhand. So the fact that it's a shortcut kind of means that it kind of shields you from stuff that might be going wrong. It becomes a black box. You code something that goes in, and you're not always fully aware of what's coming out. Anyone who follows me on Twitter or reads my stuff will know that I'm a massive proponent of object-oriented CSS. For me, object-oriented CSS promotes a much better understanding of the whole CSS spectrum. It promotes a better understanding of dryness, abstractions, specificity, reusability. And these are all things that it addresses in vanilla CSS. These are things that happens at the root, and it promotes a much better understanding. Now, once you've nailed this kind of knowledge, this way of working, I believe that that can be combined extremely well with a preprocessor. Basically, it all boils down to the fact that a preprocessor won't solve your problems. A decent knowledge of architecture will. So objects are better than components. Alright, by this I mean that there's been recently a shift towards a more componentized web, and it's a really good shift. If you remember the Starbucks style guide that got heavily retweeted recently, think about things like Twitter's Bootstrap. These are very componentized frameworks, very componentized, reusable ways of working. But I think we can take this further. Components are still quite cumbersome. You can't really reuse your site's main nav, so why componentize it? Look at your components and look a level deeper and try and spot repeatable design patterns, try and spot abstractions. You can use a nav abstraction far more than you can use your full main nav. Anything that throws a list into horizontal mode can be used way more often than your entire clunky main nav component. So look a little deeper. Your objects are design patterns. They're very, very vaguely named. They're very, I've got here the in-semantic classes. I've put in-semantic in quotes because it's important to remember that there's no such thing as an in-semantic class. It's either sensible or insensible. Objects are purely design patterns. They don't have any branding to them. They don't have a look and feel. They're just skeleton. Nicole Sullivan describes it as structure and skin. And the objects are the structure. These are like scaffolding. The example I've got here is the media object. Anyone who isn't familiar with the media object, it's basically a little thing that it allows you to have any image-like and text-like components side by side. It could be an album cover with a track listing next to it. It could be your Twitter profile image with your Twitter name next to it. It could be anything. And the fact that it's called media doesn't really lend itself to much, which makes it incredibly reusable. The first style sheet number 1 on SkyBite.com was full of objects and abstractions, little design patterns that I could reuse over and over. Next you have your extensions. These extend your objects. These are much, much more specific in both their purpose and naming. Here we've got user avatar link, so this could be an extension of the media object, which is the user avatar link. Extensions combined with objects are what make your components. You might have a nav abstraction that puts the thing into a horizontal list of links. Then you extend it with main nav to make it the main nav component. You reuse the common design pattern, but you skin it up on an individual basis using your extensions. Working this way, you'll find that your CSS begins to have a good one-to-many relationship with your HTML. If we look at the nav abstraction as an example, we'll find that we've got a simple 8-line chunk of CSS here. All this does is takes any list, an ordered list or an unordered list, and gets rid of the bullets and puts it all in line. This just makes a horizontal list of links. Now we can reuse this over and over. We've got here that class once, but it underpins 5 different components. We've got a site nav, we've got our breadcrumb trail, we've got sponsor logos. We don't even have to use text, it could be images. Writing this class once, we can reuse it over and over and over to solve the same problem. We can solve the same problem several times, but only ever writing the solution once. If we take a real-life example of the nav abstraction, here we have my profile page on Favorite. Now, apologies if you can't see the screenshot very well, it's quite a long page, but you should be able to see a lot of red boxes there. Each red box, of which there are 45, is an instance of the nav abstraction. Now, to say 45 is cheating a little bit because there are actually only 9 unique instances, but even so, we've made 9 completely unique components underpinned by the same 8 lines of CSS. And it's examples like this for me that really prove the power of object-oriented CSS. We've solved that design pattern problem once, but we've managed to use it 9 times on one page alone. Across Favorite as a project, I can't even imagine how many times it's been used, so many times. You'll find that the easiest way to keep CSS maintainable is to avoid writing it. And the nav abstraction basically allows us to write a solution to one problem once and use it over and over and over. It stands to reason that if you're writing less CSS, the less you will have to look after. And I guess statistically, the less CSS you write, the less chance there is of things going wrong. The less chance there are of things going wrong, the more robust your build becomes. It's important to write as little CSS as possible if you want a maintainable project. Okay, if we take a real quick case study from something I did at Sky then. I did this a couple of weeks ago. We had a user actions menu on the site, and it's basically, we refer to it internally as the My Account menu. Basically what it was is you're a logged in user and you get this menu. There's only one on a page, and it's a list of links, and you'll see the circular icons to the left. Each icon was different depending on what the link did. The links were things like check your account details, check your billing address, see what things you subscribe to. So each icon was different. It was built as a single component, and it had one ID on the UL and lots of descendant selectors to drill down to the different things in the list. And that's fine, right? Surely that's fine. It's a one-off component that can use an ID. Yeah, surely that's okay. Or is it? Now, I'm fairly sure I've probably lost a few friends at Sky in doing this, but I took it upon myself to refactor this work. And the first thing I started by doing was I started looking for repeatable design patterns, abstractions that I could sort of take out and make reusable. The first thing I spotted was the idea of a big blocky list. You see this design pattern over and over and over. All it is a blocky list of any content. No bullet points, sort of full width, blocky, full hit area links. It's a really common design pattern. It could be the last 5 tweets from the Sky Twitter account. It could be the latest news stories on skynews.com. It could be anything, and because it could be anything, I gave it a very, very generic class name. I called it UI list. It doesn't lend itself to any type of content, so we can reuse it on anything we like. The next thing I spotted was the icons. Now, something as tiny and design-led as an icon, we should make incredibly reusable. Now, of course, before we were using descendants and classes on the allies to pass in the background image, meant we couldn't sprite these icons up. You can't sprite fluid elements, so we lost a lot of performance benefits there by not having spriteable things. So we've got this little spriting element. It's not something I've invented. Google have used it for a while, Yahoo have used it, it's in Twitter's Bootstrap. And all you do is you make a little empty element, in this case it's an I with a class of S for sprite, and you can give that empty element any dimensions you like, and then pass your sprite sheet in through an extension class. So now we've got an element which is just as portable as an IMG element, but entirely spriteable. So now we can move our icons anywhere we like and reuse them anywhere. The next little abstraction I spotted was icons with text. This is a very, very common design pattern again. It could be your email address with a little envelope next to it. It could be the Twitter bird with your Twitter name next to it. It's a really common design pattern that we should abstract out to make reusable. So I just made a little icon text abstraction. And what this does, it just wraps the icon and the span of text, and it sorts out all our spacing. It vertically aligns the icon with the text. And it acts as like a handle around it. So that means that we can move the icon and text as a single unit, because the icon text wraps both of them. Now, the final thing I noticed was this idea of split items. Now, the easiest way to sort of imagine this design abstraction, or this design pattern rather, is if you imagine a restaurant menu. Down the left you've got a list of meals, and down the right you've got their corresponding prices. It's just any content to the left with a small amount of content over to the right. I abstracted this out, a little split component. This was actually born on skybet.com. We had a list of potential outcomes for a sporting event, and down the right hand side we had the corresponding odds that we were offering. A very, very common design pattern, and you could build a restaurant menu out of this bit of code. This abstraction could underpin a restaurant menu. These are all design patterns. You don't care what they're actually building, you just care about what they visually construct. So now our user actions menu went from one component to a big blocky UI list filled with lots of different components, lots of different abstractions. We can pick and choose what we put in. Nicole Sullivan describes it as building websites with Lego. The more discrete and tiny the individual parts are, the more versatile things you can build out of them. You can pick and choose what you want. You could drop an icon very easily. You could not have a splitter component because you don't have to code it into the markup. It makes your front end a lot more versatile. The user actions menu then, we dropped the ID and we used a lot more markup and classes. And the HTML did increase a little bit, of course it did. We used a couple more elements, we used a lot more classes to add styling rather than descendants. But it meant the CSS shrunk massively. The CSS became absolutely tiny. I compressed the bespoke HTML and CSS after I'd refactored it, and the gzip bespoke code to build this menu weighed 147 bytes less than Google's own favicon. That's a ridiculously small amount of bytes. I think that equals around 400 bytes for this My Account menu. Now I've made sure I put the word bespoke in there because I didn't include the objects and abstractions in that final figure, and this is because when you measure impact to a code base, objects and abstractions come free of charge. You write them once and they are potentially infinitely reusable. When you measure impact to a code base, you should measure bespoke code. You should measure code that can't be reused. That's the expensive stuff. That's what bloats style sheets. Objects abstractions, things that can be reused, you treat those as being free of charge. You write them once, use them over and over. Right, well, I've just blitzed through a lot of quite theoretical stuff right there. Blitzed through it really fast, actually. So yeah, the next half of the talk is more tips and tricks. So you might not be able to go to the office on Monday and put into practice an object-oriented methodology. You might not be able to switch your entire workflow around to suit that, that kind of way of thinking. So the next half is going to be stuff that you could probably put into practice straight away. These are things that I come up with, again, over the last 18 months, 2 years, things that help you work, but are really simple to implement. The first sort of meta category in the tips and tricks stuff is the word that I can't say. Not going to be my favourite section of this talk. Keeping specificity low. There we go, managed to say it that time. So like I said before, specificity is one of the biggest problems with CSS projects. We mentioned important. When you start getting important in style sheets, it's because of specificity. When you start having to make more convoluted selectors with IDs in them, it's because of specificity, and it's important to keep it low at all costs at all times. I'll go through each of these bullets in its own right, starting off with IDs. Anyone who follows me on Twitter, again, or reads my site, will know that I cannot stand IDs in CSS. There's literally no point in them. Anything you can do with an ID, you can do with a class, and more. You can reuse a class. You can do more with a class than you can do with an ID. Chris Coyer made a fantastic CodePen demo recently, which showed that an ID is 255 times more specific than one class. It takes 256 classes to override the ID, and that's ridiculous, that's enormous, that's of no use to anyone. We just shouldn't use IDs because you can't get over that specificity hurdle without using another ID. Then to get over that one, you need yet another ID. You get yourself into this downward spiral of specificity hell. A lot of people defend IDs saying that, well, it's a unique component, therefore an ID makes perfect sense. I don't need to reuse it, therefore why should I? But as we just proved with the My Account menu, that's not really true. Even though it's a single-use component, you can still spot repeatable design patterns in it. You can make one unique component out of lots of reusable aspects. So there is literally no point using IDs, and if you're going to work on large-scale CSS, you need to stop using them right away. Writing rule sets in specificity order. Anyone familiar with Jonathan Snoop's work on SMAX will already know what I'm getting at here. But I used to be a nightmare for this. What I used to do is, when I used to write a style sheet, I used to write it in an order that reflected the anatomy of a HTML page. And what I mean by that is I'd start with my reset, then I'd follow it with the main styles, my HTML element, my body element, my main wrappers. Then I'd have my header CSS. Then I'd have my page CSS and my typographical stuff. Then right at the very end of the style sheet, I'd have my footer CSS. That's a very, very naive way of working. It's very stupid. It's a bit daft because it doesn't take advantage of inheritance in the cascade. It doesn't take advantage of all the things CSS is best at. So instead of writing in occurrence order, you should write in specificity order. So start with your reset, your ground zero, get your starting point out of the way. Then add your elements. What does an OL look like without a class on it? What does a block quote look like without a class on it? Then add your objects. Your objects and abstractions like your nav abstraction or your media object. Add these next. Then after those you have your components, which are made up of objects and abstractions. So you might have your site's main nav. You might have your user actions menu, that's a component. And finally, at the end of the style sheet, you have the most specific stuff of all, which I refer to as style trumps. You might have a label element, which is grey, but if there's an error in the form, that label might turn red. So you'd add that with a class of error. So error will trump any other styling because it always takes precedence. These go last because they're the most specific. I've also got here that subsequent rule sets should only ever inherit and never undo. What I mean by this is, if you write sort of overly overly specific CSS on a very generic, low specificity selector, you might often find yourself undoing stuff. To take an example, imagine you've got H2, curly brace, all your font styles, then padding bottom 1em, margin bottom 1em, and a border bottom 1 pixel solid grey. Every H2 now has a bit of padding on the bottom and a little key line underneath it. That's all well and good until you want a H2 that doesn't have a border. And the problem you're going to have here is you need to invent a class like noBorder, which is horrible. And noBorder, that's job would be to undo the styling you'd set previously. Another thing to look out for as well as important is to look out for undoing styles. That's a sign that something's gone wrong. What you should have done is had your H2, curly brace, font size, font weight, font colour, those kind of things, then add a class of headline further down. And headline would add the border bottom and the padding bottom. So as you go down your style sheet, you'll only ever be pegging styles onto what's come previously, never taking away. Avoid qualifying selectors. So a lot of people still do this, a surprising amount of people still do this. Here we've got an intro class that just styles up the first paragraph in a blog post a little larger. But we shouldn't use p.intro because that's overly specific. We could have got away with just using one class, but now we've introduced a higher specificity by having the element in there. By having p.intro, we have increased the specificity unnecessarily. Perhaps more importantly though, perhaps more worryingly, is now we can't use .intro on anything else. We can't use .intro on, let's say, the first list item in a to-do list, or the first comment on a blog post. Qualifying selectors is pretty unnecessary and it increases specificity. If you want to override p.intro, you're going to have another class and an element at least in order to do that. Avoid unnecessary nesting. Now, unfortunately, unnecessary nesting is that unnecessary that I kind of struggled to come up with a decent example. This one's a little contrived. But imagine a carousel. We all know what a carousel looks like. You've got your viewport and a series of panes that slide in and through and out. Here we've got .carousel space .pane. We've got two classes there. That is literally double the specificity of just using .pane. It's literally twice as specific as it needs to be. And that doesn't sound like much, but again, in order to override .carousel.pane, you'll need at least two classes again further down the style sheet. Try and keep it as low as possible. We don't need to nest, so we shouldn't. Now, preprocessors sell nesting as something of a benefit, something of an advantage, but it really isn't, and it should be avoided at all costs. It just increases specificity by, it can get to an order of magnitude. Avoid chaining selectors. Now, this one's quite annoying because chaining selectors are really useful. It's a nice way of saying if this and this. But the problem again here is we've literally doubled the specificity. We've got two classes now when we could have had one. What I do is I take the previous two classes and I create a third one, which is an amalgamation. So now I've got just the same amount of information. We still can see that it's a .error message, but it's half the specificity. These are real simple ways to keep specificity low, and as long as you can keep it as low for as long as possible, you'll find that the project's a lot easier to maintain. So avoid chaining, avoid nesting, and avoid qualifying selectors. So that's it for the specificity-based stuff. A few more tips to do with how you author and format style sheets then. So this is a tip that I really like. I've been doing this for a while now. Indenting rule sets to mirror the DOM. Imagine you've got a developer and she needs to make a carousel, but she can't find where the carousel markup lives. Perhaps it's buried in the CMS, or perhaps it's in one of any number of includes. You might have thousands of includes in the code base and she can't find the markup for a carousel. We can sort of give her a helping hand. We can't give her the full answer, but we can give her a helping hand by indenting our rule sets to mirror the DOM. Here we can see that a carousel has a class of carousel, and it has one child called panes, which has a child called pane, which in turn has two children, which are siblings of each other. We can glean all that information from the CSS alone. Just by looking how we've indented our rule sets, we can get an idea that our DOM should look something like this. It's a really simple thing to do, but it's a really nice thing to have, to be able to get a visual snapshot of the DOM just from looking at rule sets. Anyone who works for an agency, particularly an SEO marketing agency, probably sick of this phrase, but the good news is if you're a developer, content isn't king, comments are. I think that comments are vastly underused, surprisingly underused. Of course they're useful for things like this fixes so-and-so bug, or see so-and-so blog post for how this works. But I have, over the last sort of 6 months to a year, been working on, dare I say, cleverer uses of comments. Comments on steroids, comments for power users, if you will. I believe people should write more comments, and if you're working on a big site, you're going to have a build process which strips comments out before go live anyway, so be as verbose as you can be. I did some quick calculations before this talk. I wrote a framework for Sky, a CSS framework, and just as a little test, I stripped all the comments out of it. I didn't minify it, I just literally got rid of the comments. And it turns out 45% of that framework was comments. Now that's quite a hard number to get across just how big it is. For every 100 bytes of CSS I wrote, 45 of them did no styling whatsoever. Nearly half of that style sheet was worthless after go live. That's how many comments I've written, and I believe that all developers should strive toward the same. Comments are probably the most useful thing that any language has. So one of the things I came up with very recently was the idea of quasi-qualified selectors. So we covered how you shouldn't qualify selectors for specificity reasons, but unfortunately doing so can be quite useful. Let's say you've got a breadcrumb, and any decent front-end dev will know that a breadcrumb should be an OL, because it's a hierarchical snapshot of where you are in the website. But a guy who spends his entire day buried in PHP, he might have to build a CMS component. He might not know what element the breadcrumb should attach to. Well, looking at our CSS, you can see that, right, it goes on an OL. Similarly with the product page. A name like product page, you'd imagine it goes on a high-level container. But does it go on the HTML element? Does it go on the body element? It might even go on a div further down the DOM. We can't actually explicitly tell people that, look, product page goes on the HTML element, I've got it here, I've just commented it out to keep specificity low. Quasi-qualified selectors pass on a lot of information without impacting specificity in the slightest. Right, so I'm a little odd in that I like to work in one giant style sheet if I can. And it's not about right or wrong. A lot of people prefer to shard over a dozen style sheets. They're not wrong, I'm not wrong, no one's wrong. It's just a preference thing. My reason for liking working this way is because it's handy to have my entire project on me at all times. I've always got the entire site's CSS at my fingertips. But of course, if you're going to work this way, you need to organise your style sheet very well. The style sheet must therefore have a very generic name, because it can't be called anything specific because it contains everything. So it's really important that you have a table of content. Imagine a developer comes along and he needs to edit the site nav. Now, he knows that some CSS already exists for it, but he's not sure where. He can just read down our table of contents and see there is a site nav section. He can see right away that the CSS that already exists for that comes just after the main section. And to get to that section, he just needs to do a find for $siteNav. The purpose of the dollar here is to signify that this string is a section title. If he'd just done a search for siteNav, he'd have got the string siteNav in the table of contents. He'd have got siteNav in that class there. By prepending section titles with $, you can skip straight to sections. You can limit your search scope to sections only. Now, of course, if you're working with Sass, you might get conflicts in that Sass's variables are prefixed with a $, but of course, if you're not using IDs in CSS, which none of you will be, you could use a hash instead. On a similar vein, something I came up with recently was the idea of tags in CSS. So it's all well and good if you know what section you're after, but what if you're not after a section at all? What if you're after creating a new component? You need to know what styles are available to you, but it's not in a section. So if we're making something with a list, we can just do a search for caret lists, and we can find the nav abstraction. The purpose of the caret here is similar to the purpose of the $sign previously. It just limits your search scope to tags. So a developer's come along and he's searched for caret lists and he's found the nav abstraction. You might decide that the nav abstraction's of no use to him, so he carries on his search and he might find the matrix object. And it turns out the matrix object is exactly what he needs. The matrix object is like a grid of list items that you might perhaps use for a thumbnail of images for an image gallery. We've also tagged it with tables because a matrix is a grid which looks like a table, but it's not a table. The reason for tagging it tables is because objects and abstractions are about design patterns. So this matrix object sorts out layout with lists, but it also looks like a table. A developer might need a table or a table-like component, but not semantically a table. He can find things like this. So by tagging our chunks of CSS, by tagging our objects and abstractions and also our components, we can guide developers around style sheets even if they don't know explicitly what they're after. Commented out HTML, this is probably the simplest and most useful one of them all. Remember the developer, she couldn't find the carousel? Well, even more use than just indenting the rule sets would have been commented out HTML. And the only reason I use the nav abstraction here is because there literally isn't enough room on the slide for the carousel one. But here we can give an explicit hand-picked example of the HTML we expect to be used. The best thing about this is there's no ambiguity. If a developer comes along and sees just the nav abstraction without this commented out markup, it's fairly obvious how it gets used, but not necessarily. By putting a chunk of commented out HTML, they can paste that markup into a view, refresh the page, and see explicitly and exactly how we intend our styles to be implemented. We can show them explicit hand-picked snippets of markup that will reflect how we expect our CSS to be implemented. Object extension pointers, another really simple one. If you're working in an object-oriented manner, you can have stuff sharded across different locations. So we've got the nav abstraction, which underpins a lot of things. We might get a developer come along and he's new to the project and he's not familiar with the nav abstraction. He might find it and wonder to himself, what happens next? Do I do anything with the nav abstraction? Is this it? Is this as far as it goes? Well, it turns out you can extend .nav in your theme.css. By telling him that, he knows exactly where to go next. He understands that this is just a base underlying abstraction, and any extensions should live in this style sheet. Conversely, he can be in theme.css and find some CSS in there, and he can see back to where it came from. So we have now got an explicit link between two different chunks of CSS in two completely different files. It explicitly links those two bits of code. These are like signposts that guide developers around style sheets. There's nothing worse than finding some CSS and not having a clue at all where the styles came from. You've got firebug and you're tearing your hair out trying to wonder what's inheriting from what. By writing object extension pointers, we can explicitly tell people where those styles are coming from. Right, so I just blitzed through a hell of a lot really quickly there. I'm just going to recap some stuff then. So if you're going to work on sort of larger projects, and to be fair, tiny projects as well, projects of any size can all benefit from working this way. There are several things you can do to make your life easier. The first one is just write less CSS. If you want to keep your style sheets maintainable, keep them small. Also, what you have written, make sure you can reuse a lot of it. As we saw with the nav abstraction, reusing that 9 times in one page vastly reduces the amount of maintenance overhead we have. Anything you write should be able to be reused. Anything that can't should be carefully considered and coded in a way that it only extends other things. Let the HTML do some work for a change. A lot of people, like I said, try and do too much in the style sheets, which leads to bigger style sheets, which leads to convoluted selectors, brittle selectors, selectors that can break easily, selectors that are overly specific. By using a few more classes, you can offload a lot of the work from your style sheet and onto your markup. You'll find that both become a lot more maintainable that way. You need to write more comments. Write some comments and write some more on top of it. Write comments about your comments. Seriously, go mad. Like I said, you'll probably have or you should at least have a build process that concatenates and minifies your CSS anyway, so the comments won't hit live servers. Bloat your style sheets, massively inflate them with comments. Write about everything you do. Get some rules and make sure the team sticks to them. There's no point having this idea of tagging CSS if the rest of the team doesn't do it. You need to make sure that people understand why you're asking them to do things. A lot of these things are useless without team buy-in. All it takes is one guy to not update the table of contents. An entire chunk of CSS might go missing. Make sure that people understand why they're doing what you're asking and the benefits of them doing it. And also remember that people are human. It sounds like a daft thing to say, but CSS isn't always the problem. You'll be working with other developers, and some of them might not even be CSS developers. And I'd like to reiterate that this isn't a blame game, this isn't pointing the finger at anyone. But other people work in different ways. There's more than one way to skin a cat. It's just a shame if a guy in your team decides to use a rusty spoon. People have different techniques, and people forget things. People, by nature, are forgetful. You might have someone go on holiday for 2 weeks and forget to tell the team something before he goes. He might come back in a fortnight, and sure, he's got a lovely tan, but he's forgotten himself what he was supposed to tell people. There's a genuine and accidental lack and loss of knowledge as a result. You need to make sure that managing big projects, you're also managing the people writing the code. People are too fast to blame CSS, but CSS can be maintained and can be scaled very nicely, as long as everyone plays the same game. Right then, so if you're vaguely interested in sort of scalability and front-end architecture, these are some people I really recommend you follow and check out. Firstly is Nicole Sullivan. She pretty much invented object-oriented CSS. She came up with the media object. She worked at Yahoo and Facebook. And yeah, she speaks at a lot of conferences, and if you can catch any of her videos, I strongly recommend you do so. They're absolutely fantastic. Her site's a really good source of quite fundamental object-oriented CSS. Fundamental, but also very interesting object-oriented CSS learning. Next up is Jonathan Snook. He seems like a real nice guy. I'd love to meet Jonathan. He's just written SMACS, S-M-A-C-S-S, Scalable Modular Architected CSS. And in my opinion, it's one of the best things that's been written for front-end developers in years. And it's largely available for free on his site. It's a fantastic resource. He used to work on massive sites. He used to work at Yahoo, and I now believe he's at Shopify. So the work he's doing at the moment is absolutely fantastic for front-end developers on projects of all sizes. Finally, we've got Nicholas Gallagher. This guy's a genius. He used to work at the BBC and he's now at Twitter. Even if you're not familiar with the name, he worked on the HTML5 boilerplate. He pretty much created normalize.css. What else? The micro clear fix that people started using, that was him. Unfortunately, his blog posts are real few and far between. But anything you can find on his site is absolutely, it's a goldmine, so I suggest you check him out as well. And yeah, that's me again. So thank you all for listening. I'll take any questions if you have any. Thank you very much.